Alright, so this video we're going to look at another exponential decay problem. This will be example 3. So it says a doctor prescribes 125 milligrams of a therapeutic drug that decays by about 30% each hour. Write an exponential model representing the amount of the drug remaining in the patient's system after T hours. Find the amount of the drug that would remain in the patient's system after 3 hours, and what is the half-life of the drug. Alright, so let's go ahead and start the answering the first part of the question. Alright, so we know we've got an exponential function. A of t equals a sub 0 times e to the kt. Alright, so to find our function, we need to know what a sub 0 is, and we need to know what k is. Okay, and you can see our function will be in terms of t. T is our variable. Alright, so let's see what it says. It says after each hour, the drug has decayed by about 30%. Alright, so let's see what that means. Well, first we need to look at how much we started with. Okay, a sub 0, that's the initial amount. That's the amount you start with. And you can see in this problem we started with 125 milligrams. Alright, so if I have a of 1, okay, I'm taking the 1 hour and I'm plugging it in for t. Okay, that is equal to the amount I started with times e, and in the place of t I'm going to put 1. Okay, and that equals, okay, so here we go. It decays by about 30%. Okay, it decays by about 30%. So after 1 hour, it has decayed by 30%. So that means that how much of it is left? 70%. Okay? That's how much is left. After 1 hour of the 125 milligrams that we started with, 70% is left. So that would be the 70% times the 125. Okay? That's how much of the drug is left. So here we have a nice little equation to solve. So let's just rewrite that. E, let me write that a little better. We've got e to the k equals 0.7 times 125. Notice I didn't multiply this out because if you see what happens here, the 125s cancel. Okay, and so I have e to the k is equal to 0.7. Alright, so now I need to solve for k. So to solve for k, well, we take the natural log of both sides. Okay, so the left hand side I get k equals the natural log of 0.7. Okay, so let me refresh your memory on this how I get the k. If you remember, if you have the log of b to the x with base b, these two are the same, the base of the exponent and the base of the logarithm. If those are the same, your answer is your exponent. Now we have natural log e to the k. Well, remember, natural log is the same thing as log base e. And since these are the same, our answer is our exponent. Okay, so I get natural log of 0.7. So I can punch this into my calculator, natural log 0.7, and it's a bunch of decimal places. And for the sake of this problem, I'm going to round it to 4. If you're working the problem, you probably want to write out all the decimal places. Okay, and another thing you could do, instead of punching that into your calculator, you could just leave it like this and plug this in for K. Up to you. Okay, but like I said, just for the sake of this problem, I'm rounding to 4, but I would put all the decimal places that your calculator gives you. I wouldn't round it. Okay, all right, so there's K. So now we're going to take our value for K and we're going to plug it in here, and we're going to take the 125 and plug it in for a sub 0, and that will give us our function in terms of t. So I get a of t is equal to a sub 0, which that's the initial amount present, that's 125, times e to the k, which is negative 0.3567 times t. So that answers the first part of the question. All right. Now the next part, they want to know, find the amount of the drug that would remain in the patient's system after 3 hours. All right. So, well, all we do here is we just evaluate the function at 3. We plug 3 in for t. So that's 125 e to the negative 0.3567 times 3. And then we would need to punch this into our calculator. So let's see what we get. Negative 0.3567 times 3. So that gives us 42, and I'm going to round it to 1 decimal places. So 42.9, and remember, our time is in hours. I'm sorry, the amount present is in milligrams. So after 3 hours, there would be 42.9 milligrams. And so that would be the answer to the second part. All right. All right. So now it says, what is the half-life of the drug? Okay. So that means we want to know how much time does it take for half of what we started with to be gone. All right. So let's just write down our function here. We've got 125 e to the negative 0.3567 t. Okay, this is our function. So what we want to know is, when does 125 e to the negative 0.3567 times t, when does that equal half of this amount? Okay, so that would be 125 over 2. And so the 125 divided by 2, I'm going to go ahead and write 62.5. Okay? That's what we want to know. How long, what number do I have to plug in for t to get this amount? Okay? That's going to give us the how many hours for the half-life for half of this to be gone. So I'll divide by 125. So I get e to the negative 0.3567 t equals, and that'll be 0.5. And then we will take the natural log of both sides. Okay, So remember from earlier, the natural log of e raised to this power is just negative 0.3567t is equal to natural log zero point 0.5, and I will divide both sides. And so I get t equals, and I'll need to punch this into my calculator. So natural log of 0.5 divided by negative 0.3567, and that gives me, let's see, and I'll round it, 1.9, and what are we in? Hours? So that's 1.9 hours. That's the half-life. Okay, so that answers this part of the question. Alright, so I hope this helped. This is the third example. If you haven't watched example 1 and example 2, they're a little bit different than this, so you might want to check those out. Don't forget to like and subscribe, and thanks for watching.